Hello, class. So we are in section 10.5 now, where we will talk about inverses of matrix or the inverse of a matrix. Um, and so first, I just have the question of what's an inverse, right? We remember function inverses. This is similar, okay? But the idea is an inverse is something when you multiply, okay, a multiplicative inverse. You get one, or the identity, right? Where one is the multiplicative identity. Right? So then 6 inverse is 1/6, right? And then 1/7 inverse is 7. Okay. And so the question is, well then, right, what's 1? What is 1 in our matrix world? Okay, or what's the multiplicative identity? So you might just guess it's this thing, right? The matrix, which is ones inside. Okay. But if you look at this, right, so I'm going to multiply these two matrices. Okay, so you're going to get 2 plus 1 is 3. You're going to get 5. You are going to get 3 again, and you're going to get 5. Okay, so you see, this is not the multiplicative identity, right? Something happened. So it's not this. Okay, so you need to figure out what it is, and I will tell you. Okay, so the multiplicative identity in matrix land is actually just called the identity matrix, okay? And it has, right, for every dimension, for every square matrix, there exists one. So the multiplicative identity for a 1 by 1 is actually just the number 1, okay? But when we get bigger, the multiplicative identity is this thing, okay? So 1's on the diagonals and 0 everywhere else. That's the identity matrix. Okay, so if I get bigger, here's the 3 by 3's identity matrix. Okay, 1's on the diagonals, 0 everywhere else. And then I could probably squeeze this in here. The 4 by 4's multiplicative identity. All right, and then it just goes on forever. So these are the identity matrices. Let's show you that they work. Okay, so here I'm just gonna have an example. Okay, so let's take the identity matrix and just kidding, multiply it by that one other matrix I was trying to do. So 2, 2, 2, 2, 1, 3. So what happens? So if I go row by column, this is 2, this one's 2, this one's 1, this one is 3. Ta-da! Nothing happened, right? But remember, matrix multiplication is not commutative. So you should check this one because you know, right, it could be different. And if you check this one, so if you go row by column now, okay, you will see it is the same, okay? So the identity matrix times a matrix is the same thing as the same matrix times the identity matrix, which is just A. Okay, so the identity matrix is one of the few elements that do commute, okay? It does not matter which direction you multiply the identity matrix because nothing should happen, okay? All right, now that we know what the identity matrix is, and you could, you see that it works, I can show you an example of matrix inverses. So here, I'm going to have A, it's going to be this matrix, and I'm going to have B, which is going to be this matrix, and the question you would get is, verify. Is B A inverse, right? Are these matrices inverses? So what you would do is multiply them. So A times B is going to be 2, 1, 5, 3, 3, -5, 1, 2. You multiply them together. I guess I'll show the work, actually. So let me make this big. So if you do matrix multiplication, you're going to get 3 minus 5. Excuse me, not 3 minus 5. Let's actually multiply. 6 minus 5. And then you're going to get negative 2 plus 2. You are going to get 15 minus 15. And then over here, you are going to get negative 5 plus 6. So if you crunch that out, you see 1001. Ta-da! Okay, but honestly, you do need to check BA, all right, because I'm not really sure if it's possible. I think it literally is, but it's possible that it's only an inverse in one direction, which would make it like a fake inverse or not really an inverse. Okay, so you do need to check if it works both ways. Okay, so 3, negative 1, negative 5, 2, 2, 1, 5, 3. So let's do this. So you're gonna get a 6 minus 5. You're gonna get 3 minus 3. You are going to get negative 10 plus 10. And you are going to get negative 5 plus 6. Okay. And if we see this, right, it does work. You get the identity matrix. Okay. So therefore, all right, therefore B is A inverse. Okay, but also the other way around. All right, A is B's inverse because right they're pairs. Okay, so this is how you would verify matrices are inverse. You just multiply them together, and hopefully everything kind of cancels into the identity matrix. All right, so now if you remember from the last section, I told you if we know a matrix is inverse, we can solve systems. So let's look at this system. Okay, so if I have 2, 1, 5, 3, so x plus y, x plus 3y equals, and then let's just equal some stuff, so like 1, 2. So here I have a system, right? Which if I translate this into a matrix equation is 2, 1, 5, 3, my variables, and the answers. Okay? So this is A times X, capital X, okay, not lowercase x, equals, I don't know, call this B. Oh no, don't call that. Well, call it C. It does not matter, but let's call it C. That's an E. C. All right. Well, if I multiply A inverse, right, I get this. This becomes the identity matrix. And we know that is just X. So the answer is this. All right. Conveniently, we already know A inverse, right? A inverse is equal to B from the last problem. Okay, so it's going to be 3. Is it 3? Yeah, 3, negative 1, negative 5, 2. So that means the answer, like I know the answer is this thing. Okay. So you just need to multiply these two matrices and you're done. All right, so if I multiply these two matrices, I will get, so first of all, this is a 2 by 2. This is a 2 by 1. So I know my answer will be a 2 by 1. Okay. So you're going to get 3 minus 2, and you're going to get negative 5 plus 4. So the answer is going to be 1, 1 minus 1. Right, so that means x is 1, y is -1, or 1 comma -1. Okay. So this is how we would use inverses to solve a system, right? Is if you make it a matrix equation and then you just multiply the answers by A inverse, okay? And then we get the answer, all right? Okay, so now the next question you guys should be asking me is like, well, what if I don't already know the inverse, right? And so that's kind of, yes, now point. Okay, so we're gonna start with inverses of 2 by 2s because those are special. So an inverse of a 2 by 2 matrix. All right, so an inverse of a 2 by 2 has a special formula that we should all memorize, okay? So if I have a matrix A, B, C, D, the inverse, okay, A inverse is going to equal 1 divided by the determinant of A times D negative B negative C A. All right. So you see that all I have to do is swap these two, right? And then put minus signs here, and then I have this thing. Okay. So not that hard. So then you're like, what's this, right? What's determinant of A? Determinant of A here for this 2 by 2 will be AD minus BC. All right, so the formula in your book will look like this. AD minus BC, D negative C negative BA. All right. Okay. So, example, let's use the matrix that we've been using. Okay, so if A is 3, -1, -5, 2, what's A inverse? Well, let's use the formula. So 1 over AD, so 6 minus BC minus -5. No, wait, minus 5. So it's going to be 1. All right, and then I just swap, right? So 2, 3, 1, 5. So the answer, right, because this is 1, so the answer is actually 2, 1, 5, 3. And if we look, right, 2, 1, 5, 3. Okay, so it works. Okay, let's do another one. So let's find the inverse of just, I don't know, some random things. Okay, so here is going to be 2, -4, 3, 1. A inverse is going to be 1 over AD minus BC, so 2 minus a -12, so it's going to be a 14. Okay, times 1, 2, 4, -3. So the answer will be 1 over 14, 1, 4, -3, 2. Or, I mean, if you want to put the 14 inside, 1/14, 2 over 7, -3 over 14, and 1 over 7. All right, and then one more. So A equals 6, 4, 3, 2. Okay. So 1 over the determinant, so you're going to get 6 times 2 minus 3 times 4. And we do the matrix thing, so 2, 6, -3, -4. But then look at this, right? So then 6 times 2 is 12, minus 3 times 4 is 12, which is 0. So bad. Okay. So yes, so we instantly you see a problem. All right. So here A is not invertible. All right, or A inverse just does not exist. Okay. So that's kind of a new thing, right? With numbers, the inverse always exists, except 0. 0 doesn't have its own inverse. But here in matrix world, yeah, there's a lot of matrices that don't have inverses, okay? And this will happen. So in fact, all matrices, we have this theorem, okay? So if the determinant, okay, of A is equal to 0, then A inverse doesn't exist. All right, or and vice versa. If the inverse doesn't exist, the determinant is going to be 0. Okay. So we can see problem, right? So you should always check this, right? This is a popular trick question. Is if I'll tell you to find the inverse of this thing, and then right, you'll get a 0 here, and it won't work. All right. So and this will mean that your system is not solvable either. If you like go up here, right, to when I solve the system, if you try and find the inverse, you're going to get a does not exist system. Okay. All right. So now we have a problem. So that's 2 by 2s, right? So this is inverses for 2 by 2 matrices. It's just this extremely nice formula. Okay. What about bigger? Well, then we get a problem, okay, because it's complicated. So first, I'm going to show you an example of how we're supposed to find inverses, okay? Because the formula is special. It's not the normal way we're supposed to do things. Okay, so here we have this matrix again. I want to find the inverse, okay? So what we're supposed to do is put the matrix on the left here, and we set up like this double augmented matrix where we put the identity matrix on the other side, okay? And the goal is we do this, right? We put A here and the identity matrix on the right. Your goal is to swap it. So you want the identity matrix over here on the left, okay? And after you swap it, magically, whatever shows up on the right side is the inverse, okay? So let's do that. Okay, so my goal is to get the identity matrix, which you should be able to do, because that means all you have to do is put this matrix into reduced row echelon form, okay, which we learned how to do in the other section. So, how do I want to do this? I'm gonna do row 1 plus row 2. Okay, so I'm gonna get negative 1, 1, 1, 1, 2, negative 1, 0, 1. Okay, then I'm gonna do row 2 plus 2 row 1. So negative 1, 1, 1, 1. So this is 0. So 2, so this is gonna be 1. This is going to be, so I did a 2. So it's gonna be a 2, and this is gonna be a 3. Okay. Then I'm gonna do row 1 minus row 2. So negative 1, 0, 0, negative 1. So I'm subtracting. So I'm going to get negative 1 and negative 2. And then obviously negative row 1. So 1, 0, 0, 1. 1, 2, 2, 3. And so I'm done, right? This is the identity. So that means this thing is A inverse. A inverse equals 1, 2, 2, 3. Okay. So this procedure is what we're supposed to do to find inverses. Okay. And so that's how we find inverses of bigger matrices, okay? So let's do that. So here I have A is equal to 1, -2, -4, 2, -3, -6, -3, 6, 15. Okay, so I have a 3 by 3. Let's, let's find its inverse. So 1, -2, -4, 2, -3, -6, -3, 6, 15. And then on the other side, we're going to put the identity matrix. Okay, and our goal is to flip them. All right, so we're going to do row 2 minus 2 row 1 and row 3 plus 3 row 1. Okay, so row 1 is going to stay the same. Row 2, so 0, 0, right? Okay. So, subtract -2. So that's going to be a 4, -3, so that's going to get a 1. -2, so that's going to be 8, right? 8 minus 6 is 2. All right. And then this is going to be -2, 1, 0. Okay. And then here I'm going to get a 3, 0, 1. So I got to figure out these. Okay. So 3 times -2 is -6. So that gets me a 0, which is nice. And then 3 times 4, -4 is 12. So 15 minus 12 is 3. Yay. All right. Now here we have two options. One, I can deal with fractions and just do row 3 divided by 3. Okay. But then this is going to be a 1/3 and I'm going to have to deal with a 1/3 forever. Okay. So that's actually what I would honestly do. But if you hate fractions, you could do the alternative of multiply row 1 and row 2 by 3. Okay, so you're going to get 3, -6. I'm going to multiply row 2 by -3. -12, 3, 0, 0. 0, -3, -6. Positive 6, -3, 0. And now you don't have to deal with fractions, right? Because it'll work out nicely. So pick either one. It does not matter. Okay. But now what I'm going to do is row 1 plus 4 row 3 and row 2 plus 2 row 3. Okay. So you're going to get 3, -6, 0, 0. 0, -3, 0, 0, 3. Okay. Now you gotta be careful. Okay, so this is gonna be 3, 0, 1. Okay. Okay. So row 2 plus 2 row 3. This is a 2. This is gonna stay -3, and then 2 times row 3 is gonna be 6 plus row 2, so it's gonna be 12. Okay. All right. And then now 4. So 4 plus 3, 4 times 12 plus 3 is 15. Okay, 0, 4. All right, hopefully that's correct. I advise you all to not do what I'm doing and actually do this on the side. So now what I'm gonna do, actually, just to make things a little bit easier, is I'm gonna do row 3 divided by 3 because we're pretty much done with it. So I could do that now. And then I'm gonna multiply row 2 by -1 just to get the minus signs to line up nicer. Okay. So that results in this thing. So 3, -6, 0. 1504. Okay, so here I'm going to get 3, negative 12, positive 3, negative 2. And then here I get this thing. So 1, 0, 1/3. All right, and now I'm pretty much done. What I'm going to do is row 1 plus 2 row 3, 2 row 2. And then I'm going to divide row 2 by 3. Well, I can do that later. I have to do another step anyway. All right, so we now have 0, 3, 0, negative 12, 3, negative 2. Okay. All right, so 3, 0, 0, because that's the point. All right, now, so 2. So I'm going to get 15 minus 24. So 15 minus 24 is going to be negative 9. 0 plus 6 is 0. I mean, 0 plus 6 is 6. Excuse me. And then 4 minus 4, that is actually 0. Okay, so that's nice. So we are here, and basically I'm done, right? Because now I'm just going to divide row 1 by 3 and row 2 by 3, and then I'm actually done. So you get 1, 0, 0, 0, 1, 0, 0, 0, 1, the identity matrix. And then over here, I'm going to get negative 2, just kidding, no, negative 3, 2, 0, negative 4, 1, negative 2/3, 1, 0, 1/3. And ta-da! We have the answer. Okay. Negative 3, 2, 0, negative 4, 1, negative 2/3, 1, 0, 1/3. And that is our matrix inverse for a 3 by 3. Okay. It's long. I'm not gonna lie, very long. So, but this is how we do it. There technically is a very secret way to find the inverse if you want to calculate like 9 determinants. I will let you experiment, go on the internet if you really hate this method to find that one, but no one really teaches it. And it's only special for 3 by 3s. If I make you find an inverse of a 4 by 4, there is no special way for the most part, I think. You have to do this method, okay? All right, but now that I have this thing, okay, we can do stuff. So, if I want to solve a system, right, so let me get a system in here. Let's make it, let's do it backwards. Okay, so negative 3x plus 2y equals, and I don't know, hopefully I'm gonna try and make it nice. Negative 4x plus y minus 2/3 z equals 0. And then x plus 1/3 z equals 1. Okay. Well, right, we know this is, if I translate it into a matrix equation, this is negative 3, 2, 0, negative 4, 1, negative 2/3, 1, 0, 1/3, right? And then we have our variables. And then we have the answer. Okay, so if I multiply by the inverse, which is the original one, so this a, which I'm just gonna copy and paste. Okay, I'll have the answer. So the answer is, right, answer x, y, z is going to equal this thing, A inverse times this. So let's see what that is. All right, so the answer is going to be a 1 by 3, right, if we check the dimensions. Okay, so 1 times 1, so 1 minus 4. Okay, so 1 minus 4. I made this too big. It's awkward. 1 minus 4. Okay, there we go. 2 minus 6 and -3 plus 15. So the answer is going to be -3, -4, +12. And ta-da, that's supposedly the answer. You could check it. If you want to plug in, you could go ahead and check it. But that's the answer. All right. So again, inverses are nice, right? Because, right, if we wanted to solve this, right, we would have to do row echelon form with back substitution or reduced row echelon form, right? But here, I literally just multiplied two matrices, which is not that hard, right? It's like 6 multiplications, and then you add, and then you get the answer. Okay. All right. I think for the most part, that's it. I could do one more example, which I guess I will do. All right. So, what I'll do is this example, okay? Because this one is special. Okay, so it's another 3 by 3. Okay, so it's gonna be a long one. -3, 2, 1, -7, 7, 4. Okay. So I'm gonna try and find an inverse. All right. Now this is a cautionary tale and also a proof that your textbook is kind of bad. Because before you try and find an inverse, you should check that the matrix is invertible, right? You should check that the inverse exists. But currently you don't know how to do that because the determinant section is section 10.6. So I'm just gonna try and find this thing's inverse. Okay, so let's, so set it up. 2, 7, 1. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. And the first thing I'm actually gonna do is swap row 1 and row 2 because I kind of want the 1 here, which I guess I could subtract, but here's an example of when swapping is maybe okay. Okay, so I'm just gonna swap them. 2, -3, -7, 1, 0, 2, 7. Okay. So swap them. Okay, now I'm gonna do row 2 minus row 1, row 3 minus 2, row 1. Okay. So row 1 stays the same. These are zeros. Okay, so then I'm just subtracting. So this is going to be 1, this is going to be 3, and this is going to be a -1. If this erases, okay. 1, -1, okay. Now I'm subtracting 2, so this is going to be -5. This is going, okay, this is going to be -7 minus 8. -7 minus 8, which is -17? Or is it -15? -7 minus 8 is definitely -15. I lost my mind. Excuse me. Yes. All right. -15. 1, 0, -2. Okay. Great. Now, right, I want to get rid of this -5. So I'm going to do row 3 plus 5, row 2. Okay. So 1, 1, 4, 0, 0, 1. 0, 1, 3, 0, 1, -1. 0, 0. Okay, so now I have to figure out the other one. So 5 times 3 is 15 minus 15. So you're gonna get 0. Right, and then I'll continue. But 5, so negative what? 5? -7? Okay. But Actually, so the point is you got this to happen. Okay. So as soon as that happens, you're kind of up the creek without a paddle. Okay. This will never be the identity matrix because you've canceled out all of the zeros. Okay. So in fact, this is what happens when the determinant of A is 0. Okay. This inverse will not exist. Okay. So as soon as you get all zeros, you can stop and just tell me A inverse does not exist. Okay. So if at any point in your finding of an inverse, you zero out an entire row, that means it doesn't exist. Okay. But later on in the next section, you will find that you should just take a determinant and it'll be 0. And then this will save you some time and pain. All right. All right. Okay. So now let's finish off with one more full example. Okay. So what I mean is I want you to be able to solve this thing. Okay. So the actual question that you might see like on a test. Okay. Which I guess that would be the final because there's no more tests left. All right, solve this. Okay. Well, what you would do is you would first find the inverse and then you would do the multiplication. So right, A would be 2 negative 5, 3 negative 6. So then we find A inverse, right, which we know is going to be negative 12 plus 15. And then negative 6, 2, 5, negative 3. So when you figure this out, you're going to get 3. So 1/3. Negative 6, 5, negative 3, 2. All right. And then you know the answer, right? The answer x, or I guess if you want to do like xy, is going to equal the inverse. So 1/3 negative 6, 5, negative 3, 2 times this thing. Okay. So 1536. And ta-da, you're like theoretically done. Now you just actually just have to multiply. All right. Which I'm gonna like commutative property this thing. The 1/3 is a number and numbers commute. So I'm actually gonna like distribute the 1/3 over here because these numbers are big. So I would like them to be a little smaller. So this is going to be 5, and this is going to be 12. All right, which is a little bit nicer. And now I will get the answer. Okay, so negative 30 plus 60. Okay, and then this is going to be negative 15 plus 24. So the answer is going to be 30, 9. So x equals 30, y equals 9, or 30, 9. Okay. Ta-da! So this is the full example, right? Where you have to find the inverse and then do the multiplication, and then you get the actual final answer, okay? And you would do this with the 3x3, 4x4, 5x5. I would never ask you for anything bigger than a 3x3, okay? For a full question like this, it'll be overboard. It will take way too much time, okay? So really only focus on 2x2s and 3x3s, all right? But theoretically, you know how to do the bigger ones. It's just they would take forever to calculate. But that's it for this section. It's a pretty important one. Okay, you should be able to calculate inverses, all right, and multiply matrices, right? This heavily requires that you understand the previous sections. But that's it for this section. See you guys next section.